constant external forces, listen to me, okay? Whatever external forces that is applied to the system, like the mass times acceleration, is acting on the center of what? Gravity. I repeat again, if I do a drop, all the forces that are acting on this ruler will act on the where? Center of what? Gravity. That is why we always have to determine the center of gravity. If possible. Okay, sometimes when the geometry gets very complex, but most of the time, software are used to detect center of gravity based on geometries and mass. Okay, coming back to here now. The next question that we're going to attempt is we are going to attempt the mass moment of inertia about point G. Okay, so we are going to look at, I want to focus on this diagram over here whenever possible. So we're going to find the I, right, for the horizontal rod. Yes. Mass moment of inertia is kilogram per meter squared. Second moment of inertia is meter to the power 4. Okay, so that is the difference. Okay, when we say mass moment of inertia, is we want to detect or we want to see how the mass will resist angular acceleration. Okay, later you will see that. Well, when you learn from quick P04, second moment of area, like what I talked about in the class last week, is the resistance to what? Bending. Okay, two very different things, but someone point out that the symbol is the same, where they still use I. Okay, it is still I. Right. So from here, H rod is equal to Ig plus by md squared. Okay, so if you were to look at the horizontal rod, okay, before I go on, when you use this is what we call parallel axis theorem. You can only use parallel axis theorem if I zoom in, okay, on IXX, IYY, or IZZ. You can only use them on IXX or IYY. This one IZZ also okay. You can only use them in the what? IXX, IYY. Okay. Now, X prime, Y prime, Z prime, you cannot use the parallel axis theorem. Are we clear? Okay. So this one, you can use the parallel axis theorem. Okay. Over here, can you see prime? Yes or no? Right? You cannot use any of these at all. You can't use this, you can't use this, you can't use. And then over here, this you cannot use. Are we clear? Yes. This is because the way it's derived is from the center of gravity, and the center of gravity on individual system is all on the center. It cannot handle the offset because we are putting the offset over here already. So you can't do it twice. That's the only reason. We clear? Right. So now we are looking at the horizontal rod. Okay, so the horizontal rod is 1/12 ml squared plus by md squared. Okay, so now I will shift this. Okay, so this will be equal to 1/12. The mass we know is equal to what? The mass is 2.4. The length is 0.8. Yeah, the length is 0.8 squared. Plus the mass over here is 2.4. Now, what is the D?
Okay, the D for this case, right? Basically, if we look at the rod, so knowing that over here, this is equal to 0.888. D is from the horizontal rod to the what? To the center of gravity. This is our D. So in that context, this is equal to 0.888 squared. Okay, so this will be equal to 1/12 times by 2.4 times 0.8 times 0.8 plus by 2.4 times by 0.88 times by 0.88. Is equal to 2.021 kilogram meter square. Okay. So that is for the horizontal. No, so the next thing we look at the vertical rod. Okay, so we were to focus on the vertical rod. Okay, so the vertical rod again, we use what? Okay, so for the vertical rod, we have to use those who are center of gravity is 1/12 ml squared. So the formula is the same. ml squared plus by md squared. Okay, so 1/12. The mass is equal to 4.5. The length is equal to 1.5 plus by 4.5 multiplied by the now. The distance now we have to be careful. Okay, so the distance is equal to 0.888 minus 1.5 divided by 2 squared. So why? This is the big Y bar, which is the center of gravity for the entire system. This is the small Y bar. The small Y bar, this refer to the Y bar for the what? For the vertical rod. So that's why it's 1.5 divided by what? 2.
And all of you responded to the QR code. And then they have to write a report about your comment. You know what they use? ChatGPT. Yeah, they use ChatGPT, enter all your comments because there's 140 comments that's given about me, and they can't bother to read it. So what they do? Upload everything into where? ChatGPT. And then they ask ChatGPT questions. What they don't like about this speaking. And all the remarks came out. Bloody fantastic, isn't it? I was so impressed, okay? So one of the comments I was told, give them a 2 minutes break after 30 minutes. There you go. 2 minutes break. Right. Something off topic, okay? Right, so coming back to here. Now, so this will be, yeah, professors using ChatGPT, isn't it? Unbelievable. Don't worry, ChatGPT cannot do dynamics. Hey? Yeah, they're so bad at math. So this is equal to what? 0.929 kilogram meter square. Now, I'm going to show to you what not to do, okay? I'm going to show to you what not to do. Okay? I'm going to copy this. I'm going to show you what not to do. So I did try this when I was younger. Why not? Okay, why not? I use the slender rod in this location. And I'm going to use the formula 1/3 ml squared
Then I shift my distance. Okay, so if I were to do this, this is the wrong way. Okay, wrong approach. I want to show you all the wrong approach. Okay, so what is the wrong approach? Is that for the vertical rod, you use this formula. So you use 1/3 ml squared plus by m d squared. So i.e., we are taking the point over here to consider, and we're going to shift down by what? 0.888. So this you get 1/3 m is equal to 4.5, and L is equal to 1.5 squared plus by m, which is 4.5, multiplied by d, which is equal to 0.888. Is it 0.888? Yeah, from the top, you shift over there, squared. So this will bear a value of 1/3 times by 4.5 times 1.5 times 1.5 plus by 4.5 times by 0.888 squared. Syntax error. Even the calculator know that it's wrong. So it's 6.923 kilogram meter squared. And this is wrong. Okay, why? Because for the parallel axis theorem, this I over here has to be what? I over here has to be center of what? Or center of gravity, or center of mass. Okay, or mass. Are we clear? Okay, so very important to remember that. Okay, so next, it's pretty straightforward. We're going to do the I solid disk. Okay, so if you look at the solid disk, right? So it's into the page. We are going to. It's not into the page. We are going to use IZZ. Okay, we can use IZZ into the page. Now we cannot use IZ prime Z prime. Okay, we have to use what? IZZ. So you get half mr squared plus by md squared. Okay, so this is half. The mass of the disk is 3.393. The radius is 0.3 squared plus by 3.393. Then it will be equal to the d squared is 0.888 minus by 1.8. Okay, 1.8 because the distance from here to here to the center of gravity, this is equal to 0.3. Okay, so from here you get 0.888 minus 1.8. Oh, there's a square, beg your pardon. Squared times by 3.393 plus by 0.5 times by 3.393 times by 0.3 times 0.3. You get 2.975. And then finally, you have your I for your hollow disk. Again, is the same. So this is half. The mass is 0.377. Diameter is 0.1 squared plus by 0.377 multiplied by 0.888 minus by 1.8, and this whole thing is squared. So this is equal to 0.888 minus 1.8 squared times by 0.377 plus by 0.5 times by 0.377 times by 0.1 times 0.1. I get 0.315. So therefore, your mass moment of inertia about the center of gravity. Yes, sir. Say it again. Yeah, later on I'll put the minus over there. So this will be equal. So the first one, we get what? The first one is 2.021929. 2.021 plus by 0.929 plus by 2.975 minus 0.315. Okay. So 2.021 plus by 0.929 plus by 2.975 minus 0.315 is equal to 5.61 kilogram meter squared. Straightforward, easy. Okay, so in your final exam, I will provide you with this table. So expect to see this. Okay, yes. Oh, okay.
So like when we're referencing my notes, we don't get confused.
Oh. I circle in red, okay? Okay, wrong approach. Okay, don't do the wrong thing. Why this is what? IZ prime, okay? Cannot use. Okay? Right. Now there's another formula that you can use, okay? That I want you all to know. That is known as radius of gyration. Radius of gyration, the symbol is K. Okay. So the mass moment of inertia okay can also be calculated or be determined by I is equal to mk squared. Okay, where K or M is the mass, K is the radius of gyration. When this is given, you don't need to do what we have just done. Okay, you just use the radius of gyration and you apply this formula over here, you get your second moment of inertia. And K can be represented by square root of I over M. Okay, so like what we have calculated over here, like what we have determined over here, the radius of gyration K is equal to the square root of I over M. So I is equal to what? I is equal to 5.61 square root of 5.61, and our total mass, which we have calculated earlier, is equal to what? 9.916. Okay, so 9.916. So the radius of gyration is equal to 5.61 divided by 9.916. Square root the whole thing is equal to 0.752. So in some question, if they give you the radius of gyration and they do give you the mass, this is the formula you can apply. Are we clear? Okay, if that's the case, I'll see you guys on Thursday.
Excuse me.